Welcome to Astronomy Vault. Today, we begin our journey with one of the most iconic and mesmerizing galaxies in the night sky, Messier 51, better known as the Whirlpool Galaxy. A cosmic spiral so perfect, so detailed, that it almost looks drawn by hand. M51 lies about 31 million light-years away, in the small northern constellation of Canes Venatici. At first glance, it appears as a textbook example of a grand design spiral galaxy, galaxies whose arms are well-defined, symmetrical, and strikingly elegant. Those sweeping arms are not just beautiful shapes. They are enormous lanes of gas, dust, and hundreds of billions of stars, arranged like a celestial staircase winding through space. But their most important role is this: they are star-forming factories, compressing hydrogen gas into brilliant clusters of newborn stars. One of the most intriguing aspects of M51 involves not just its spiral structure, but the dramatic behavior of its smaller companion galaxy, NGC 5195. For decades, astronomers have known that this dwarf, yellowish system is interacting heavily with the Whirlpool Galaxy, pulling on its spiral arms and reshaping its structure through powerful tidal forces. But recent observations have revealed that this encounter is even more violent than once thought. A study using data from NASA's Chandra X-ray Observatory found unmistakable evidence of a supermassive black hole in NGC 5195 undergoing powerful eruptions. Although relatively close by cosmic standards, only about 26 million light-years from Earth, this black hole is experiencing one of its most active phases, ejecting hot gas in intense bursts. At a meeting of the American Astronomical Society, researchers presented these X-ray observations showing expanding arcs of high-energy material around the galaxy's core. Optical images from the Kitt Peak National Observatory revealed a cooler, thin shell of hydrogen gas just beyond the outer X-ray arc. This combination suggests a striking scenario: the hot gas expelled by the black hole is physically pushing the cooler hydrogen outward, transporting it away from the galaxy's center. The displaced material is massive enough to potentially ignite new waves of star formation, a cosmic process astronomers call feedback. The cause of the black hole's current outbursts may be tied directly to the gravitational interaction with the Whirlpool Galaxy itself. As M51 pulls on its companion, gas may be funneled toward the black hole, feeding it and triggering explosive energy releases. Based on the shape and distance of the arcs, astronomers estimate that the inner bubble of material formed between 1 and 3 million years ago, while the outer arc took 3 to 6 million years to reach its current position. These arcs are also unusual because they sit in a region that lies between typical zones of black hole-driven activity. They are too far from the center to be part of the immediate outflow, yet too close to belong to the vast envelopes of hot gas that surround many massive galaxies. This places them in a rare intermediate stage, a snapshot of feedback in action, where the black hole's eruptions are actively reshaping the structure of its host galaxy. Together, M51 and NGC 5195 form not just a beautiful pair, but a dynamic and evolving system. Their gravitational dance fuels star formation, triggers black hole eruptions, and continuously sculpts the cosmic architecture we observe today. Images from the Hubble Space Telescope reveal a palette rich with meaning. Blue marks hot, young stars only a few million years old. Yellow highlights older stellar populations closer to the galactic core. Red shows infrared light and hydrogen emissions from massive star-forming regions. In other words, M51 is a place where stars are constantly born, evolve, and die, a living, breathing laboratory of galactic physics. M51 was first discovered in 1773 by the French astronomer Charles Messier, who described it simply as a faint, starless nebula that was difficult to observe. Its companion galaxy, NGC 5195, was added a few years later by his colleague Pierre Méchain. But the true breakthrough came in 1845, when Lord Rosse observed M51 through his enormous telescope and sketched its structure in remarkable detail. It was the first galaxy in history where a spiral shape was clearly recognized. In that moment, humanity glimpsed the architecture of the universe beyond the Milky Way. Even today, the name Whirlpool Galaxy reflects the swirling, almost hypnotic motion Lord Ross saw nearly 2 centuries ago. M51 is the dominant member of a small group of galaxies that also includes Messier 63 and several fainter companions. Its distance has been debated for years. Estimates once ranged from less than 20 million light-years to more than 35. Modern measurements place it at around 31 million light-years, though small variations still exist. What's certain is that M51 is both large and luminous, making it one of the most studied and photographed spiral galaxies in the sky. With an apparent magnitude of 8.4, the Whirlpool Galaxy can be spotted with a small telescope under good skies. Its face-on orientation makes it perfect for amateur astrophotographers, a galaxy that reveals its structure openly, almost inviting us to explore its spiraling depths. Every image captured, from backyard telescopes to Hubble's instruments, adds another piece to our understanding of how spiral galaxies evolve. M51 is more than just a beautiful swirl of stars. It is a cosmic interaction sculpted by gravity, a window into star formation, and a landmark in the history of astronomy. And as we continue our journey through the universe here on Astronomy Vault, the Whirlpool Galaxy reminds us of something simple. That even across millions of light-years, beauty and motion follow the same laws that shape our own cosmic home. Thank you for watching. If you enjoyed this first look into the universe, feel free to stay with us for more explorations in the Astronomy Vault.